Hi, I thought I'd try to do a problem and record it while I'm working live, so we'll see how this goes. Appreciate your response at the end if you like this better, worse, or about the same as where I just post my work in the regular discussions. So let's see what we got here. We've got a hypothesis test. Yes, this is chapter 10. And notice it says mu equals 40 versus mu is less than 40. So we are testing the mean of the population. We want to know if the population, the mean, really appears to be 40 or if we're thinking it's going to be something less. Sample size is 25, which is kind of small, right? We normally want it at least 30, except it says from population that's known to be normally distributed. So that means we're good. N can be any size, and we can still run the test. We just have the old practicality that we want N to be large enough to work with. Okay, so when this sample was run, standard deviation of the sample, X bar, 36.9. Ooh, that is less than 40. Is that enough less that we can say there's some significance to it? S, the sample standard deviation, 12.2. So they want the test statistic. Well, the first thing I'm going to do is say, I'm going to run this on my calculator because I'm not going to do this stuff by hand. So, all right, I need to run a t-test because we do not have the population standard deviation. And I don't have a way to actually video my calculator. So I input the data and I chose the test t-test. So you notice that the input is stats. We got statistics. We don't have to put in raw data into L1. So here we got mu sub 0, our hypothesized mean, 40. X bar, 36.9. SX, which is the standard deviation of the variable X, 12.2. N is 25. And less than the null hypothesis, less than 40. And we're going to hit calculate. And here we go. It's my results. Okay, so I can't have them both on the screen at once, but notice T sub 0, test statistic, that's what the calculator calculates. So negative 1.270, it says 3 decimal places, negative 1.270. No, negative 1.270. Normally, I just have my calculator handy so I can see it. All right, let's see how we're doing. Yay, so far so good. Okay. Researcher decides to test this hypothesis at the 5% level, alpha 0.05. So we need to look this up on the table. And we also have N is 25, so degrees of freedom, 25 minus 1 is 24. So we've got 0.05, 24 degrees of freedom. All right, degrees of freedom 24. And we're going to go across to 0.05. So right there, 0.05 and 24, 1.711. However, this is right tail, and we are doing left tail because we're saying less than the mean. So it's going to be negative 1.711. Okay. Pressure's on here, folks. All right. what I was just talking about. I actually wish this were before this. You know, why are we talking about a negative value? Notice that the critical value is negative because it's the left tail. And also notice that our test statistic is over here somewhere. So we're in the correct tail. We're not doing something weird. So I'm going to say it's A. All right. What else we have to do here? Continue. All right. So now they want to know, will the researcher reject the null hypothesis? So remember, if it's more than 1.711 standard deviations below the mean, then we're going to reject. This is that low probability area. The area right there is 0.05. Okay, but we're at negative 1.270, so it's right about there. Sorry, I can't draw on here. So I would say no, we're not going to reject because no, it does not fall in the critical region. All right, it's not so unbelievable. You know, it's like, oh yeah, we could get that answer. That'll happen sometimes. Whereas out here, we're gonna say, oh, that's really rare. We don't believe it. All right, let's see. Oh boy. All right, so there you go. Now, the other thing we could have done is instead of using critical value, we can use the value of P, the probability. And if probability is less than 0.05, we would reject. But P was 0.108. So again, if you think about this, we have a line drawn up here at negative 1.270. This area is bigger. It's about 10%, 0.108. So again, we would not reject. The two methods always agree because as we get closer to the mean, the value of alpha, the probability is going to get, not alpha, the probability is going to get larger and larger, all the way up to 0.5 if we actually got the value of the mean for our hypothesis test. All right, so that's it. Let me see, get rid of this guy. Boom.